Okay, good morning, everyone, and sorry that we are a little bit late and the technical setup needed some time. Online participants, welcome to this tutorial. This one is about network automation with Salt. My name is Awal and I work for APNIC. We do technical training and configuration assistance in the Asia Pacific region. For today's tutorial, before I start, I'd probably do this Menti slide deck first very quickly, even though we don't have like really very big participant base here. How about you? Close the door. Okay, yeah, let's start. I have this slide. I didn't cover the rest of the world, mostly the Asia Pacific. Who joined the Menti? Can you show your location from where you are? When you select the location, submit, and then it should give us some spot here. Okay, I can see Hong Kong, Pakistan. We actually have only 3 people joined, so yeah. Okay, the next one. Write hello in your local language. How do you write hello in your local language? Difficult? Nobody's writing. I wish I could read that, but I can't read that. Assalamu alaikum, walaikum assalam wa rahmatullah. What's in Hong Kong language? Like in Cantonese, what is the hello? Is it hello also in Cantonese? Oh, great. Okay, if you guys want to join this menti.com and use this code to join this, this is nothing to do with the automation though. Okay. This is a quick question. Even I'm not 100% sure which one is the national animal in Hong Kong, but I just put a couple of options. There is no right or wrong answer here, but you have to select something. Actually, I was looking at the internet. I was looking for what is the national animal in Hong Kong, and I found two in two different web pages. So I'm not 100% sure which one is correct. Okay, so far what I knew from the internet is it's probably dolphin. Even even Hong Kong citizens may not know that like it's dolphin as their national animal. Um, but yeah, panda. I also thought panda, and one of the websites says it's panda. But anyway, next one. What do you think for this one? There is no right or wrong answer, but you can select any of the answers. Actually, today's topic is network automation with salt. So I just put this question. So you select salt. Yeah. Okay. Next one. Um, what is the role that best describe your interest? Number four. You like number four? You can number four. Okay. Yeah, somebody actually picked number four. Okay, next up, yeah, I can see sysadmin and network engineers, which means this topic can be very relevant to the participants. Mm, this is my last slide. Um, do you use automation in your network operation? It's dangerous, so I don't touch it. I don't do it. It's probably dangerous and yeah. Um, yeah, some of you, okay, all four options here. So it means that we have a combination of different groups of you know engineers who are using automation extensively, and some of you are already doing it probably every day. Some group of people probably once in a while, moderately, and some might not yet started. So I'll just keep it here, and I'll go to the presentation deck. And once again, um, happy to have all all the different group of engineers here who are interested to do that. So for this session, I would ask you to go to academy.apnic.net. When you go to this website, you see we have many different um, activities going on. But the first one of these training events on the list in that web page is this training or tutorial that we are doing today. So please click on that link. You should be able to reach to the event page. And why my internet is not good? Maybe I'm not using the proper SSID. How about now? I think I'm still with Zoom. So, okay. So once you are in this page, there's some information related to this training, but I want you to go to this course materials, please. And then if I extend it, so this is pretty much what I need today. I need you today to follow this one. So this is the slide deck that I'm gonna cover, and there is a lab today. In the second session, we'll do some lab that probably gives you more idea about what we are talking. Yeah. Okay, let's do the presentation deck quickly, and I've tried to cover it briefly because this is like a very big slide deck and I may not be able to finish all of the slides, but should be able to give you enough information to go ahead from there. So like I said, my name is Awal and I work for APNIC, and we do several different topics. We do training on several different topics, and network automation is one of these topics. The first question we usually have in your mind actually is whether it's needed for us or not. So to identify the need, better to start with what is it? So the network automation, you can define it really very differently in different cases. For example, for some people, network automation probably means setting up the monitoring system, doing it automatically and collecting information and showing you the result. So for some network engineers, the automation is to do configuration management. For very, very large companies, like big companies, network automation means they want to build a network that requires very minimum human intervention or human interaction with the system because their infrastructure is too big, probably too complicated for person to manually do all the changes every day and things like that. So the definition varies, but we can agree on one, simple definition is if anything I need to do repeatedly, let's say to run my network, then we may think of instead of running it every day by a human being, we can do some programming to do this task automatically by the system. That could give us several benefits. And I'll come to the benefits, but that could be something. So this task will require minimum human intervention. And because it's a repeated task, I have to do it very regularly. I would not probably look into that anymore. I probably focus on somewhere else and do some more different work. So minimum human intervention. Bigger companies define the network automation even in a bigger scale, in an extended kind of manner, is that they want to build a network that can try to solve problem by itself. What does that mean? Is, for example, if one of your router interfaces is down, one of your router interfaces is down, usually what we do, a human being go and troubleshoot. But the troubleshooting pattern is quite similar. We go there, we try to shut, unshut, we try to see some of the logs and stuff, things like that. So if some of the primary troubleshooting can be done by the system itself, and if it fails, and it can send you a notification saying that, I tried these things, but it didn't work. So you now come and log into the router and see. So this is kind of a level 1 troubleshooting. So the system should be able to do this type of level of troubleshooting. For example, there could be a NTP synchronization lost with one of the routers. And what are the other options it can have? Probably it can try to get the synchronization back by doing some of the troubleshooting techniques. And then if not, then it will just send an email or a Slack message or any other way. It will inform the network team that this is not working. So what are the benefits? Like I said, human being, we make mistakes. The more we configure the network, there is a chance that we may mistake, we may configure something mistakenly, putting a different IP address and things like that. If there is an automated tool there, we have to make sure the first task that we do has to be accurate, and then repeatedly that task's accuracy will be maintained. Easy to audit changes. Whenever there's a change, you see the logs, and your audit or the annual audits or network audits will be easier with those logs. Peer reviewing. If I just configure something, usually you will see many organizations when they do the troubleshooting or configuration changes, they maintain the proper SOP or standard operating procedures. But in many other companies, you might see that there is no such, standard operating procedures maintained. With automation, what you can do is if you build something, you can have it be reviewed by your peers or your managers. And then if everything is okay, then you deploy it, things like that. It's easier to do that. Easier also to implement with the CI/CD pipelines. Whatever task has been done with the tracking of version controlling, it's also possible to see the changes, as well as whatever automation impact has been done or changes has been done in the system can also have been logged, and the historic actions can be reviewed later. So why we know, and now who and when should we automate? Actually, if I see some work can be automated, I can start doing it now. So you shouldn't like think about I need a very big, very good solution and very different type of customized solution for my work. But whatever tools at the moment available in the market, I can just try and see some of them, whether it can do my job, what I wanted to do. So there are many open source tools, and we'll see Salt because it's also open source. So which tool I should use is also a question. Definitely you can choose out of many options, you can choose one of them. But considering your network size, or how big is your network, or how many devices or different types of vendors equipment you have, means the diversity of your network, and how frequently you need to change configuration in your network. Considering all these factors, you may do some comparison between some candidate tools, and then select whichever is the best suited in you for your need. Something called event-driven automation means if there is an event, the system or the tool itself can initiate or can react. It's called event-driven automation, and that's why Salt is something that can actually give you flexibility in terms of all these different criteria that we have just seen. But that does not mean Salt is the best tool. The tutorial we are doing today is not meant to say that Salt is the best tool, not like that. It's just another tool, okay? And probably Ansible is already been used by many network operators, many tools, which is also a good tool. So there is no point here we are making that Salt is best and rest of them doesn't have those benefits and things like that. But let's just learn a tool here, okay? So Salt's benefit is it's very fast. It's asynchronous, means you give a task, but you don't wait for the reply. You can give another task, and the reply can come later. So it's asynchronous and fast. It has a very fast communication bus that can listen and give result. It can support very large deployments as well. very, very big companies, for example, let's say Cloudflare or DigitalOcean, who every day who had so many requests from the customers, which is very complicated to respond or to take action with a human being. So these type of big companies definitely can get benefit out of these features in Salt. It has a very, very good support from different vendors modules. So when you do automation, module support is a very big thing. If you don't have acceptance to different vendors' platforms, then it's so hard for you to implement a module and do that. So the more vendors welcome the tool, or the community welcome the tool, it becomes like a very strong tool. Okay, so Salt has a huge module and function base that can talk to different vendors equipment and then can do what task you want to do. And we'll see in the lab during the second session, you'll see that how the modules can be a great benefit when we do automation. Okay, this is a simple architecture of. By the way, if there is any question from you, please feel free to stop me anytime and ask question. Let's make it a little bit more interactive. And also for the audience online, please feel free to ask questions and we'll have some discussion. I'll try to make it as simple as possible. So this is a very simple architecture of Salt. So we now see there are two major elements. One is called master, the others are called minion. Now, master is kind of the brain or the controller. And the minions, they are the executioner, or they will actually take tasks from master and will execute it in the device. So, in short, one device that I want to manage will have one minion to take care of that. And if I have many device to manage, I have to have one minion for each of the device. And the one master can actually maintain communication with all the minions that I have. Of course, there can be, limit to how many I want to manage, but that's a huge number. In short, one minion, one device. But one master can have many minions. Okay. This one is an extended version of the previous diagram. One minion can receive tasks from multiple masters, but this minion will actually maintain the communication with one device. Now, this minion is supposed to live inside the device. That's why it's called an agent. Okay? So the minion is supposed to live inside the device. For a Linux server, it's so easy. You just install minion package there, right? But if you have a router, how can you install minion over there unless the vendor supports it? Unless the vendor supports it, right? So for example, I have a Cisco router and I don't have a Ubuntu like CLI over there where I can say, apt install this. It's not going to work. For that, we have a different solution. So agent cannot live inside the box in that case. So the agent will be outside the box. So in general, minions are supposed to live inside the box, which is possible for example, Linux servers or any other vendors who actually implemented it. But otherwise, we have to find a different solution where minion can still talk to the device, but without living inside the device. Okay. The master can be anywhere as long as master and minion can talk to each other over the internet. They can live anywhere else in the world, doesn't matter. So I already covered that, like minion is the agent and it's definitely talking to the master. So one master can actually maintain a huge number of minions depending on the resources and the processes that's needed to run that. How the communication happens, it happens over a 0MQ or zero messaging queue channel. And the minion listen to, so there are default ports which is customizable, but the minion listens to port 4505 and the master listens listen on port 4506. That means when master sends some tasks to minion, it's basically target the minion's ID and then starts talking by sending task or sending instructions to the port that the minion is listened to. When minion finish or minion executes the task, the result is sent to the master with the master's ID or master's IP address or host name with the port that master listens on. Okay, so that's how the communication happens. So at the beginning, when master boots up, it doesn't do anything. Basically, it's just wait for minions to come to the master and say, hey, I am a minion and I am ready to take your tasks. I'm ready to receive your instructions. Okay, so master boots up, it doesn't do anything, just sit idle. Minion, when it's up, it needs to have master's information because it's the tool that will first initiate the connection request with the master. Okay, so minion needs to have the information of the master in order to start the communication. When the minion asks the master, hey, I am a minion, I just got started and my configuration has your name as my master. I want to be your trusted partner or trusted contact. Can you accept this request? So the master needs to accept this minion's request and become a trusted partner by exchanging the keys. So this public-private key, this PKI system works here as well. So master accepts minion's public key, minion accepts master's public key, and that way they can do the encrypted communication. There are some terminologies that we need to do before we go even further. So we understand how the installation and the relation starts with minion and master. Now, how about the configuration? We have to go with some of the configuration, right? So there is one term called ops or options. Usually these are the configuration options of Salt itself. So any feature you want to enable, for example, if you want to do this communication between master and minion with IPv6, you can say IPv6 true. Okay. Pillar is the configuration data for the Salt in order to, if you want, what task you want to give, that goes, or what configuration you want to apply, that goes in the pillar. And I know at the beginning, these terminologies are actually a little bit confusing unless you really see what is the pillar, where it lives, and how it works. But at the moment, just remember, pillar is the configuration data. Usually options, we usually at the beginning, while we test the tool and we do some small tasks, You don't even need to go very detail of the options, what options salt gives you. You really at the beginning may not be needed to tweak all these configs. But pillar is important. That is the configuration information. Something called grains. Grains are attributes of the target device. For example, what is the version of that device, or what operating system the device is running? What is the serial number of that particular node, or what is the MAC address of an interface there? These are the granular information coming from the device with the help of the minion. These are called grains. Even with Ansible, it's called facts. Ansible has this something called facts. So you can actually collect information from the device, and then based on those information, you can program the task. For example, if it is a Ubuntu operating system, you probably need to use apt install something to install something. If it is a different operating system, for example, CentOS, Red Hat, or CentOS is dead, I think. Actually not dead, but somewhere living. But let's say Red Hat, you use yum install instead of apt install, right? You got the point? So if you can ask your minion, give me the OS. And if the OS is Ubuntu, use apt install. If it's some other OS, you use their specific. So you can actually program based on that. For example, if it is a Cisco iOS, configure hostname with the command hostname something. If it is a Juniper or Junos, you give the command set hostname and then set system host minus name, actually, to be specific in the command. So grains gives you more information about the target so you can program properly. Okay. In short, pillar is the automation data or automation configuration information. Grains are the attributes, but ops is not really configuration data or the attributes. Ops or options are options of salt. Either you can enable or you can disable and things like that. That's with the ops. Okay, now proxy minion. Like I said, if you cannot install the minion in the device as a living agent inside the box, then you have to have a solution to that. Means automatically the concept brings you here where minion will live outside but will maintain the communication with the device. So that's called proxy minion. Proxy minion is like a regular minion just outside the device. So this scenario, now the minion has two hands. One is towards master, collecting instructions, and once the task is done, giving reports. The other hand of the minion, proxy minion, is talking to the device. Now we know minion and master, this communication happens over 0MQ channel, right? Already we understood that this happens over 0MQ. How about minion to the device? Previously, it was inside the box. So there was some management plane communication, right? But here, the device and the minion, they will be able to talk to using different ways like netconf, HTTPS, SSH. These are some of the communication method that they can use. So netconf, HTTPS, SSH, these are the communication channels, communication methods that the proxy minion can use to talk to the device. The other communication, other side is between the proxy and the master, which remains the same as the normal minion, okay? It makes sense? I think so. Okay, so I already covered it. And now, so where can the proxy minion run and how the whole system can work? Because I said I might have 5,000 nodes to manage. and none of them may not have any minion to be installed there. So since proxy minion is a very small process, we can run it in Docker containers, we can run it in VMs, we can run it in servers. It can be in many, many different places. It's a very lightweight application. So bigger, very, very big companies who needs thousands of minions to manage their thousands of devices, they usually run it maybe in containers and then manage it with Kubernetes. Now, configuration of Salt, because Salt is really very extensive, and it adapts so many different methods of configuring and programming. So the most important I think is the YAML and Jinja that we need to know, and I think pretty much other network automation tools also utilize, especially Ansible, they utilize it. Very, very fast and quick is, there are three things we are going to talk about YAML, but definitely it's not that simple. You need to know even more detail if you want to go. So YAML is called yet another markup language. I think they changed the name now. It's YAML ain't markup language now. So very confusing. It was like yet another markup language, and then suddenly they said it's not markup. So, but yeah, so YAML ain't markup language is the elaboration. Oh, here, it's actually here. Okay, now what is the way it represents data? It represents data in a key value pair. So on the left side, we call it key, and the right side is the value of the key. It's kind of a variable, and this variable's data is this one. So you can just simply think like that. So location Brisbane. If you call location, you get the Brisbane as output, something like this. So interface name, and so key value pair will have a colon and then a space. Yeah, can somebody help? Yeah. So that's the key value pair. So this is the separator, is the colon, okay? So rule number one is this, you can have more, for example, interface enabled colon false means basically interface is shut down. You can simply say that. Now, second rule is indentation, which is very, very important, and you will find so many errors if you don't maintain the indentation. So indentation, in simple rules, what you can do is you can just use a common format of two spaces if they're layered and dependent configuration. For example, this interface is Ethernet 000 and its enabled key has a value called true. So they're actually one thing but layered as a dependent configuration. So each of them are indented by two spaces. Okay. This one, even more detail. For example, I have three interfaces, and so you see the indentation. This is part of interface. This one is also part of interface, and this one is also part of interface. So they're all two spaces indented as a layer of the interface, and then each of the interface has their dependent configuration as layered with two indentation as well. Okay. Now, third rule is dash. So that dash means list. One thing can have multiple values, and in that case, you can use for example, I have 3 NTP servers. I can use the 2 indentation and then a space for each of them, means it's a list of values for one key. Okay, now combining these couple of features together, you see interface, I have 2 interface list of interfaces, and then each of them has their features or information mentioned just underneath. There are some Boolean, yes, no, on, off. These are basically Boolean expressions, you can say. For example, if you say enabled true or enabled on or enabled yes, that basically means 1. If you say false, no, off, they're all 0. Now, if I need to write something which is called on, how can I write it? Because if I write on, it's basically going to read, let's say, if I want to write yes or true, if you just write true, it will interpret it as Boolean 1. So in that case, you just use double quote to make it a string and not interpreted as a Boolean value, okay? So for example, here, I want value on as it's on, O-N. So I just make it a string, okay? Multi-line text, you just use a pipe here, and then underneath 2 indentation, multiple lines, just maintain that, and then that's a multi-line text. So the advice or the suggestion here is, whenever you have texts, just do double quotes instead of keeping it like that. Even in many cases without the quotes it works, but being in like a common standard procedure in your case, you can just maintain whenever you have text, just use double quotes. Now Jinja, so we talked about YAML. It's like a serialization format, data serialization, formatting, or representation. But Jinja is the templating engine. And we know the template, we know what is a template. For example, the email template. If I need to inform my customers like regularly with the same message, or whenever there is a link down, I say, we can see your link is down, our team is working, and this something like this. Or if you have a regular kind of email, but you just need to change some values there. So you make those values variable, but rest of the text is like same. That's called a template, right? Now, template is basically a format. Based on the change of certain values, the whole message gets changed, right? Or the information gets changed. So you have a program, you have some lines or codes, and there is some variable that needs to be filled with the input data. That is the template. That is the templating engine, how it works. So let's see an example. If I say interface is, for example, if I say interface is gigabit Ethernet 0/0/0, that's a static information. Okay. This line is like this, but if I make it programmed, and I want to change the interface name based on the interface that I'm dealing with, I can make this value as variable. Okay, so let's say I made this line interface is, and then I put a variable here. If I replace this variable with my input data, the message is going to be like this, and if I change this, it's going to be changed to a different interface. So that's a template, and when the template is basically can be just a straightforward line without even any programmed or any variable. But then what's the point? So template, you will see usually this variable kind of thing, and then how do you know they are variable? You will see double curly braces there. So anything that's within double curly braces is a variable. And then you need to have input data to replace that variable to get the output, okay? So here, this is my variable, and this is my input. I get this output. If I change this input, it's going to be changed. Now, the second type of configuration you might need in the template is condition. So I'm saying, if my interface is 10 gig 0/0/0, the interface is a 10 gig Ethernet. If the interface is GE or gigabit Ethernet 0/0/0, the interface is gigabit Ethernet. Anything else is a different type. That's what I want to verify, okay? So I started with if and it's ended with end if. How do you know it's a conditional template? It's because this time single curly brace with a % sign, and then ends with the opposite format, % and then curly brace. Now, if I pass this logic, this one, this line, in this condition, the answer will be the interface is a gigabit Ethernet because it will match this format. So the output will be the interface is a gigabit Ethernet. Okay. There can be different many other conditions we can use, and in our lab we have some. This is loop. So for loop here, again similar. You can see the condition, but here for the interface name in interfaces. So I need to check this interface name. What is the value for this interface name? Every time the value in the interfaces, for example, I have several interface with different values. It will pick one, it will pass it here, and then do no shutdown. Okay, usually how do the for loop works? It's similar to Python, similar to Bash scripting. This is the case. So you have several values here in the interface. The first value will be taken by this variable and put here, and then this action will be taken, right? Then that comes back. Second value is taken as this variable's information and then put here and then execute. And as long as there is value in this interfaces, it will go all the way to the last one, and then finally once it is done with the complete list of values, it will just end the loop. So here's a example that's coming from this one. So this time we have interfaces 3. So this one has 3 values. The first one is taken as the value of this key. So the first one is 100 gig, let's say. So the interface 100 gig 000 no shutdown will be the action. It will not stop there because there are more values. It will come to the second value. It will take the value here and then no shutdown. Similarly, the third one. Now, this is a pure YAML syntax, and this is something called salt stack state or SLS. SLS is kind of a combination. You can use YAML syntax and also can use the Jinja templating together in the same file. So that is the SLS that can utilize both of this combination. And here you can see interfaces, and there's the values. These values are programmed. So usually I was talking about the beginning that interfaces has multiple value, means it's a list of values. But this list of values is programmed with the Jinja templating. So that's like the SLS format. You can utilize both of the feature in one place. And these files ends with .sls. So the salt understand that it's a SLS file. So how did this thing becomes that? So I am saying that I have a range of 36 numbers, and for each of the number, I want to create interfaces like this, but this I is the variable. So the ET00 first one will be 0, then 1, 2, 3, all the way to 35. That means total 36. So that way, this SLS file will generate this if I run. Okay, you got the point? It's going to be a little bit boring now. Seems like unless the lab is done, it's going to be boring. Okay, so SLS, like I said, it can be a combination of other different types of representational language and the templating engine. So it can be different types of combination. So by default, it's YAML Jinja. But if I want to, for example, this one, if I want to represent it in a Mako JSON combination, then it will look like this because it's a JSON syntax, right? So if you don't write anything at the beginning, it will by default think it's a YAML Jinja combination there. But if I want to use something else, I have to mention at the beginning. It's also for the shell scripting as well. If what bash or what shell you want to use, you put at the beginning, right? With the hash and then the exclamatory sign. Okay. Now I think after this part, this session is going to be a little bit more interesting if you know, if you do the operations almost regularly in your network. This part is going to be interesting. Okay, so the proxy minion, we said it's outside the box and it needs some sort of channel to talk to the device. And we said like it can be netconf, SSH, or HTTPS. So something called napalm is a open source tool that has a huge module base. Each of the module has different types of functions added there, and this napalm can actually be used by the proxy minion to talk to different vendors' equipment. So napalm has been heavily utilized by Salt because of its very well acceptance in the community and in the vendors' interoperability as well. For example, every vendor has their modules. Almost all the renowned vendors have their modules and functions defined. Many community developers, they also build many of the modules by themselves whenever there is no extensive support or huge, the configuration opportunity with the napalm for that particular vendor. The community also build some of the open source one. But of course, all the renowned vendors, Juniper, Cisco, Arista, Nokia, you'll see there, Ubuntu and Linux operating systems. What you can do with napalm, you can do configuration replace, which means change of configuration in a device, right? Previously, there was something, I want to change something. You can do configuration merge, like you have already some configuration and you want to add a new configuration. So merging the existing configuration with the new configuration, you can do a compare. Remember, this feature is in Juniper, where you can do a compare. It's also available in Cisco iOS XR. But if you have worked with some of the other vendors, for example, Cisco iOS, Arista, Nokia as well, I think, Huawei, if you do a command, it's just executed, right? If you write hostname something and enter, it's done, hostname changed. But in Juniper, if you do that, it's not done yet. You have to do commit to apply the config. So when you change something, it becomes something called candidate configuration, which means it's waiting for you to commit. That means your existing configuration is already there. Now you made a new configuration, it's not yet applied, it's saved somewhere else, and you now have two things to compare. If you are happy with the comparison, and if you see that new config is something that you want, you do commit and then it's done, right? So this compare feature is in some vendors, and you will see many of the vendors doesn't have those features. But if you use napalm module, it has inherent feature, something called compare. So if you use a proxy minion to manage a Cisco iOS router, natively, Cisco iOS does not give you the feature to compare, but because the proxy minion is talking to the device and maintaining the connection, it will then give you the compare feature. So it's not the Cisco iOS feature, it's the napalm's feature that Salt will utilize, okay? Interesting thing. We'll do the lab and then you'll see. Every time I'll find something interesting, I'll say, when I do the lab, then you'll see. Okay, because no way I can show you now. Okay, so discard. If you want to, if you have a configuration you don't want to apply, you can just discard that. Commit, again, saving the candidate configuration or saving the configuration that's you just added. That's commit. Rollback. You had a previous configuration and then you applied some new configuration, but you are unsure whether this configuration is going to create a problem or not. So you give a timer and then apply the config, and you say that if I don't do anything else, just roll back to my previous configuration, ignore my current configuration. And if you're happy, you just do another commit. That's called commit confirmed. Once you do the confirm commit, then it's not going to roll back again because you were happy with the output and actions that's taken. How you install napalm? Pip install napalm. Netmiko, another open source, similar but not really that feature-rich tool like napalm. Napalm is very feature-rich, very well accepted by the community. Netmiko, weaker features, or maybe a smaller number of options you have, but it's still useful in some cases. It maintains over SSH, but napalm you will see netconf is the communication method for that. PyEZ or Juniper specific tool that's called Junos EasyNC. It does not, this driver, this module is not available for any other vendor. Only Juniper built it for its own automation. And Juniper is, I think, ahead of the automation kind of features compared to some other vendors. Kapirka is built by Google. It's open source now, and it can generate access list. So if you say like, from this source to this destination, accept, and then it will, and you say my device is Arista, it will generate Arista specific ACL for you. If you say my device is Juniper, same information, but you say Juniper, it will create a Juniper specific ACL for you. So that's called abstraction. So you really don't need to know specific vendor's command syntax. You give a abstract information, and then it gives output like specific to the device. For example, here, Kapirka's, so this is a module, and this is the function where we say create ACL called named my filter, and if there is any term like Juniper has filter name and then term name, but in Cisco we don't have term name, so it will become a description name. And then this is the source, this is the destination, and action is accept. Build this build an ACL with this configuration. So once you run that, you'll see that it will create an IP access list, and this name will be here. Because Arista does not have the term name, so it will just become a remark for this term, and then the permit IP host this. But if you write Juniper here, it will give you a Juniper specific command with the same information. CLI syntax, how you work with Salt CLI. When you install Salt, you are in the master node now, and you want to give an instruction to the minion to execute in a device, okay? So here, Salt, I might have some options. We'll come to the options soon in this slide deck, but Salt means I'm telling the application that's in my master is Salt. I'm saying, talk to this target. The target is not the device, because master is not going to talk to the device. By default, it's not going to talk to the device, but you can have this configuration as well. But in like general terms, master is going to talk to whom? If it wants to execute a task, minion or proxy minion, right? So master is going to target the proxy minions or minions, not the device. So this target is actually the minion, okay? And then it will utilize some of the functions are part of the module. So you have one module, it can have so many different functions, okay? And these are predefined programs, predefined or pre-built features. And then you might have more arguments to even be more specific to that task. So here is an example. I'm saying there is a minion called router1. So master is targeting or asking router 1 to do a task inside the device that the particular minion is maintaining with or managing the connection with, okay? So it's saying that, hey, router 1, can you do a test.ping in the device that you are now talking to or you are part of? So if it can do this, it's similar to the ping we do, right? Whenever there is something we want to test, there is no action, just testing whether it works or not. So test.ping is one of the functions. So test is the module, and this module can have many functions. Ping is one of the functions. And then when you do that, if it is okay, if it can talk to the device, the minion will say, hey, the output is true, means my ping is successful. So master now knows my minion can actually talk to the device, so I can give more tasks. There can be many different tasks. For example, this is an argument. I was talking about some argument. So as you can see, I'm saying, give me raw output. Raw means JSON in salt. So here is a salt JSON syntax output. You can have many different functions. For example, grain.item, because we know that grains are the granular information in the device. So version, serial number, MAC address, IP address, every single small information is grain. And these grains, I'm saying, grain, give me items. Means from the grain, give me the item information. From the pillar, give me items. From the config, give me items. From the system documentation, give me all the documentation, or give me only the documentation for test.ping module. So you can add arguments to make it more specific. Even more. This is NAPAN. So NAPAN, usually you will see there are many configuration management modules are there. Here I'm saying, I'm using netmiko, and I'm saying send this command. So this is a function. I'm saying show version, send this command by using router 1, and then it will give me show version output as if I'm in the device and doing the show version command. Okay. I can do configuration management as well. It's like, you are getting a show command, but how about setting the values? For example, in a Juniper router, I'm using send config instead of send command. I'm saying send this config, and the config is set system NTP server this, and also set system NTP server this. So 2 different commands, comma separated. And if it is netmiko, it's a little bit tricky. You have to use the first you have to use single quote to identify the whole command. Then comma separated multiple commands will be like this with square bracket. And then finally, for the whole command string, you have a double quote, which is a little bit tricky. Juniper has its own way. So they develop their own modules and functions. For example, if you want to change the host name of a Juniper router, you can use one of their modules built, and you can just say the host name. You don't even write the command. You say, use this module, and I know this module is used for host name change, so just give this new host name, and you know how to write the command. I'm not gonna memorize it. You are basically utilizing the feature of that particular function. So this is the target identified by the minion ID. So don't think this is the device. This is the target. This is the minion, basically, that's maintaining the device. Now, more argument, okay? Like more options, you can say. I told you that there might be many options. So first of all is if I want to target multiple with a specific name of the minion is -L. L is for list. So this is a list of minion I want to target in once and want to do the same function there. I can have many of them. Now, network engineers are very lazy. They will not definitely type so many names there. They have interesting way of dealing with it. It's called globing or globing. Yeah, it's called globing. So salt router star means any minion, its ID starts with router, and then there can be many other characters. I don't care if it matches with the first couple of characters, router, and then run this command. So this time, I don't even need to use any options there. So shell globing is the built-in one. You don't need to mention any of the options for that. Now, what are the globbing options we have? Star means match any characters after that. If you have a question mark, match every single character. For example, if I say router and then question mark, means it can be router 1, 2, 3, 4. So it's one character. Router 1, 2, 3, up to 9, 0 to 9, whatever. Or you can have, another, instead of digit, another number or another letter. If I have a sequence with the square bracket, for example, 1 to 5, that means 1, 2, 3, 4, 5. So you can, if you say router 1 and then 2, 3, means router 1, 2, and 1, 3. If you have not sign, the not in like network engineering or programming language, in many cases you use exclamatory sign. So when I do messaging with my network engineer friends, if I say I'm coming, if I say I'm not coming, so I just say exclamatory sign coming. And they're thinking like I'm coming. Actually, I'm not, because there is exclamatory sign at the beginning, means I'm not coming, right? So you can think about it. So next time, do all the messaging with the regular expressions. For example, some countries' visa application has the weird question. It says, write down the name of the countries you visited in last 10 years. And now last 10 years, and they gave you only, let's say, 10-digit space. How can you write 10, like whatever countries you visited in 10 years? So you can use regular expression, right? Anyway, okay, now this E is for regular expression. For example, router /D. So basically you are saying after router, there can be only one character or decimal number, not character, decimal number. But if you have more than one, you use plus. So this can match router 1, 2, 3, 4, 5, something like this. But this one can match router 1, 2, 3, 4, 5, 11, 12, 13, 100, 200, 1000, basically any number after that, okay? This is grain. So I'm saying that I'm asking Salt to find any minion that is managing devices which is a router. So how do the minion know whether that's a router or not? It's the grain data, okay? Whether it's a Ubuntu server or not, whether it's a Cisco router or not, it's the grain data. So when I'm targeting minion that managing some device where I need to use the grain, I have to use -G. G is for grain, okay? P, it's called PCRE, Perl compatible regular expression. So -P, and then I can say model colon MX, and then any number. That's why I say /D plus, means any number. So any Juniper routers MX series router, any Juniper MX series router is a match in this target expression. So that because it's a PCRE or Perl compatible regular expression, I'm using -P. If I use based on pillars, instead of -P, it's -I. So how you remember that? I remember it as like a pillar. It's like a pillar, like I. It's like a pillar, okay? So proxy host, and I'm saying that this is a proxy module for the host, that the host is basically VMX any number, which is another Juniper router. This is J. This time I'm targeting pillar, but with Perl compatible regular expression. So this is basically similar thing, but you can see I can use the regular expression here. But previous one, I just used shell globbing, not the PCRE, okay? Here, this is a PCRE compatible one. If I want to use many of these different structure combining together, I can create compound logic here. So that's why -C. So this one is saying, the master is saying, whoever is managing routers, this means any minion with the name router. And if you are managing Cisco's equipment, because this is a grain, so this time grain is not here. So if you want to build a compound logic, you have to use -c, and then the rest of the commands, rest of the syntax will have to be based on their characteristics. So G at means this expression is grain expression. But I cannot use -g because I have to use -c because I'm combining different types of expression together. So G vendor Cisco, so who are the minion IDs, their name start with router, raise your hand. And if you are managing Cisco's equipment, you are the one that I'm looking for. And also the model of the device has to be NCS and the version has to be 702. So you can now ask why I need that. You know, some of the cases where the vendor just released a patch. Okay. There is a, for example, there is a vulnerability exposed for some certain models router and you have about 10 of them. Okay. Instead of going and finding every single one and do this manually, you can build this kind of complex logic and then can identify the devices at once. Okay. Even more, you can build this logic where the Boolean like and or. Okay. For example, any minion start that their name starts with router, you raise your hand. And also if you are managing a Cisco NCS version 702, I'm looking for you. Or if you are doing Juniper MX whose version is 7.3 routers, you are also okay to execute this command. Okay, you can build this. So this is an or, but within the or, each of the expression has and means all of them has to be a match, or means either of them is okay. Now comes to the node groups. It's another feature, another good feature. For example, instead of building this complex expression every single time, what we can do is we can put this in a name. So for example, router and GOS Junos, these are Juniper routers. And let's say Nexus OS, and these are Tor switch, these are my Nexus Tors. Next time, if I run command on these names, this is basically gonna be these things. Okay, instead of every time writing the whole expression, I can put the expression in a key value pair. So the left one becomes my variable. If I now execute this Junos routers as a node group, then it's basically gonna look for this because it's already defined. Okay, this way you can program it even more. In order to know more, you have the help options, of course. You can have different arguments or different other options. For example, output. If you want to save the output in a file, you can do this. For example, I want to save it in a file here in this temp directory with the file name. If I want to read the documentation, I can read the documentation of a function. There could be static results for this device that we are going to execute. There's progress bar, batch size, running the command in batches, fail hard. If there are multiple tasks, if one of them fails, don't go and execute anything else, just return. Summary of the task, the result in a glance. You can mention if one task fails, how long you are going to wait for that to be executed. You can make the timeout values adjusted based on your need. Usually it's 5 seconds, but you can do more because some of your routers may be slow to execute because they are probably old. Okay, you will see when you run the command, some vendors, some model is very fast to execute. Some vendors models are a little bit slow to execute. So if you just put 5 seconds and they take longer time than 5 seconds, then master thinks, oh, that's unreachable. Not like that. Anyway, there are more options. How about our time? I think I don't have time, right? It's almost like another 1 minute, just one more minute. Okay, let's give, we'll stop after this one and then we'll go for a break and then come back and then we'll see the lab, okay? Now, advanced configuration management, there can be very, very complicated and advanced config management. For example, this is a top file. A top file is a very important file in Salt. Basically, when you give a task, the Salt master goes to the top file. And there you said which minion will execute what task. So I'm saying all the minions you execute ntp.sls, lldp.sls. I'll put my task in the SLS file. Remember, I can configure SLS file with Jinja templating and the YAML syntax together. So I'm saying any device, not any device, any minion, these two tasks will be executed. If it is the minion starts with router or its role is router, just execute BGP and MPLS. So any router, let's say router 5 is a match here, right? How about here? Is it a match here? It's also a match here because it's star. So whoever is a router, whoever managing a router, execute NTP, LLDP, BGP, and MPLS, all four. If you are a switch, NTP, LLDP, and STP. Okay, you can make the instructions like this. So this is the first file that the master will look at to understand which minion will be executed with which of the instructions. The one I covered already. So if it's a router 1, I'm asking router 1 minion to do state.show top. I want to see what type of top file instructions you have for router 1. Router 1 matches with star, which means NTP LLDP, and also matches with router. That's why BGP and MPLS. If I look for switch matches with star, that means NTP LLDP, and it also matches with SW, and that's why it's going to be STP. This is called state file. State is something that I want to achieve. I'm saying that, hey, you are a router. I want you to come to that stage, and a router with an expected stage means a configuration to be applied. You understand this? Like in our human sense, I say configure this. But if from Salt perspective, if I put the configuration somewhere and say, hey, you bring yourself to that stage, is the same thing, right? Apply the config. So I know what I want to do. I put the task in a file and I say, apply the state. Okay, that's called, so state is basically a task with instructions and with the module that will be able to execute the thing. So this is the name of the task, which is called state ID. And then this is the module that can execute the task. And these are the values or arguments that you want to do with the task, okay? So let me give you an example. It will be easier for you. So I'm saying that router 1, you do state.apply of example.sls file. So where is my example.sls file? This one is my example.sls file. I'm saying use this module and do this argument value pair. So when I execute this on router 1, it will basically show me like this. And finally, it will give you a report. Hey, you know, I executed this state ID with this function and result is true and I was successfully done that. And what is test.nop? You know, test.ping is a function. Test.nop is nothing. That means you are basically testing whether it's possible to do, but you will not do anything. So you're just basically testing whether my minion can actually be able to do something there or not. And you have like when it is done, how many milliseconds it was there to take. Now, very quickly before going for break is I can have multiple tasks in state file. So here is, you see, example 1 is one task, example 2 is another task, but I'm saying example 1 requires example 2 to be executed. So it doesn't matter where example 2 is mentioned in the whole file, it will look for it first to execute before the example 1 is executed. So it's a dependency or a chaining of tasks. I can even do differently with the order. So here the order is 101, here the order is 100. So when it goes through the file, if there is order command, it will look for the lowest order first to execute it first. So this one will be executed first. Even though it's put somewhere at the bottom, it's going to be executed first because of the order sequence. And so this one will be executed first, then it will come here, it will say that, yeah, I cannot do that because it's a requirement to do this one, so it will come here, and then finally it will be done, okay? On changes means if there is a change, then only do that. So these are the logic, like required can be one on changes. If there is a change, then only next task will be done, otherwise no. On fail, if this task is failed, then only do that, otherwise don't do. Watch, you just look at some other functions, other states, but it's just for information. So you are watching whatever happening, okay? Okay, I'll stop here and let's go for a break and come back at 11:45, okay? Is that okay? Yeah. For online folks, we are taking a 30 minutes, huh? Is it 10:45, right? Yeah, we'll come back at 10:45. It's basically 25 minutes you are getting. You lost 5 minutes when I actually took 5 minutes from you. Okay, so yeah, online folks, we are coming at 10:45 here in Hong Kong time, which is UTC +8. So it's basically 24 minutes from now. Thank you. See you soon.